G'day guys. Today we'll be looking at confidence intervals. Now, depending on how confident you want to be that your mean is correct, so our mean value being the central value there, we're going to be allowing for a variance obviously from the mean. So we want to be able to say when we're looking at these questions that we are 90% confident that our mean lies between a range of values. So we have a lower limit and an upper limit. And yeah, it's a way of testing whether our statistics are actually genuine statistics. All right, so keeping in mind from our previous video, we are going to be looking at this concept over here in terms of our x bar take this. Now that comes from our sample, that's our sample mean, a standard deviation here that we're looking at there. And this value here comes from our z-score. Now I'll just show you how to get that in terms of looking, so you don't need to remember this, but I mean it's probably just as easy to write that on your cheat sheet anyway. So if I was looking at the 95% confidence interval, when I was looking at this example here, what I'd need to consider would be that the area on either side of this one's done for 90%, this area would be 2.5%, which would be 0.25, wouldn't it? Okay, so if I'm now going to my calculator and I want to work out what that z value is, what I need to do is I need to go to my distribution down to number 3. Now, if I put my value there, so the top and the bottom, so if I was to do the bottom first, that's probably the easiest one, so that would be 0.25. Oh, I've got two decimal places there. 0.025, and then remember our standard setup is our mean is at 0 and our standard deviation is 1. So if I go into do that, I get a value of minus 1.96 roughly. And if I do the same thing again now and I go the upper end, so number 3. So if that's the case, then that would be 0.975, wouldn't it? 2.5%. And do that and I should get positive 1.96. So that's why these things, when we come to looking at our confidence intervals, that's why that's 1.96 take and plus 1.96. all right, so if you do the same thing for the 90, so you use 0.05 and 0.95, you get this value here. And you could do this for all of the other variables as well. So if you're looking at 98, then you go plus or minus 0.01, and 99 would be plus or minus, so this would be plus or minus 0.01 for your z-score. This one here will be plus or minus 0.005. Okay, because remember 1% divided by 2 is 0.005. Remember this one here was plus or minus 0.25, and this one here is plus or minus 0.05. So all you're doing is using your z-score, and we're using our interval to find these values. Now, like I said, it's easy to do it on your calculator, or it's just as easy to write this table down on your cheat sheet. All right, so you need to have those. The thing that you have to understand is the variable that's going to change are these variables. The confidence interval then is essentially the same, but you're just changing these values here in each case. All right, so it's pretty easy to do. Now let's have a look at doing a confidence interval question, because I think that's going to bring things into perspective for you. So we'll just talk through an example first, and I'll do one for you. So here's an example. We've got 60 yabbies taken from a dam. We take their weights, and their mean weight worked out to be, and you've got to identify the key information in the question. So 84.6, and it's got a standard deviation of that. Find for the yabbies the 95% confidence interval, and then the 99% confidence interval. All right, so because we're taking a sample, it's a sample mean, and this is a sample standard deviation then. We put that information into our formula, so that's because we're looking at the 95, it's 0.196 plus 0.196. The value that goes in there is the 19.6, which is our standard, over the number, and that is our mean value of 84.6, our sample mean. And again, over here we're putting those values into the formula, and then we get the particular value. Now, how do you do that on your calculator? Well, it's pretty straightforward really in terms of doing it on your calculator, and I'll show you that in a second. But if you wanted to, you could just do that calculation on your calculator and get that value. All right, so I'll show you when we do in our example how you do that quickly on the calculator. Now, when you're doing a 99% confidence interval, it's exactly the same. The only thing that changes is this value. Okay, that's our value that's in front of the thing over there. And notice what you've got here is that particular range widens. To be 99% confident that your mean falls inside that particular range, that range has to be widened. So the way we actually represent this information, so we could say we're 95% confident that the population mean weight of yabbies lies between 83.5 and 88.85. Over here, to be more confident, we have to say we're 99% confident that the mean weight lies between 79.1 and 90.19. Now, obviously, if you want to be more confident, then that makes your range bigger. So if you're less confident, if you just want to say, oh, but 95%, we'd expect that to be obviously a smaller range. Now, even if I went to 90%, I would expect that range then to be, say, 81 or 82 back to 87. So I'm going to get a smaller range of values there. Now, on your calculator, you're going to use this Z interval, and that's how you do your data, okay? And you can put your confidence level in there. It's pretty easy to do. All right, so what I would be expecting for you to do is I would expect you to write this down into the right formula. Okay, so if I was doing this one here, I've got 42 patients from the drug rehabilitation program, shows the mean length of stay is 38.2 days. So I'm going to go 38.2 as my mean value take. Now, if I'm going to go 90%, right, I'm going to go to my table. I've already written these down, of course. So I know these, I can just use these off the table. I can't remember it offhand, so it's 1.645. Okay, so it's 1.645. So I'm going to write that in there, 1.645. My mean value, my standard deviation, is going to be what they've given me. So my standard deviation is going to be 4.7 divided by the number. Okay, so the number of patients, which is 42. Okay, so you might as well just do that on the bracket. And that means that my mean lies somewhere between there. So my mean is in fact somewhere in there, and it's a sample mean. And then all I have to do is repeat the same thing on the other side. 38.2 plus 1.645, and then we've got 4.7 all over the square root of 42. Okay, now it's really important when you get used to these questions is, you know, identifying that information. Okay, that's the key information that you need for the question. So once you've done that, it should be easy. Now, if you go to calculator, all right, you need to go into your stat button here, and we're going to go do some tests. Okay, so you have to go to the test bit. All right, and so we're going down to the Z interval, which is number 7 on our thing. So you get quick, you just type in 7. All right, so we're doing our stats. Okay, so we're going to put in our standard deviation. So our standard deviation was in fact 4.7. Right, our X bar there, our mean was 38.2, I think, by memory. Our number of samples was 42 patients. The confidence level that we're looking for is 90% confidence interval. Now, the good thing about this, it actually does it for you. So it tells me that my mean lies somewhere between 37.07 and 39.393. Okay, for that information. So it actually does all that work for me, so I don't have to actually do any calculations apart from put it into my calculator. So if we go here, what we can say is that's 37.007. Right, X bar and I think that was 39 point, can't remember, I better go back to that, 0.393. Alright, so 393. So what it means is I'm 90% confident that the mean length of stay so you need to put in context of the question, for a patient is between 37.07 days and 39.39 days. Alright, so that's how you do your confidence intervals. Pretty easy. Have a go at those questions. If you need some help, then please make sure you catch me in class.